Okay, so this is section 1.7 on transformations of functions. So we're going to see what happens when we have different numbers plugged into our function to make our function shift to the left, to the right, up, down, reflect across the x and y axis, and even stretch and shrink a little bit. So when we're transforming the function, we're talking about the parent function that we learned last week. And when we throw in different numbers with the function, that is the transform function. Okay, so first, a horizontal shift is when you see a number in parentheses with an x. When that number is greater than 0, that's a shift to the left C spaces. When that number is less than 0, that's a shift to the right C spaces. So I always think that it's the opposite of what you think it's going to be, because in the parentheses, if it's x plus 5, then it's going to go to the left 5 spaces. If it was x minus 3, then it would go to the right 5 spaces. So when it's in parentheses, remember it's the opposite of what you think. Okay, next is a vertical shift when you have a number outside of the parentheses. When that number is greater than 0, that's a shift up that many spaces. When it's less than 0, that's a shift down. So when the number is not in parentheses with the x, it's by itself, then that's a shift up or down the same amount of spaces and in the direction that makes sense. Next is a reflection. So when there's an x in a parenthesis, that is a y-axis reflection. When there's an x outside of the function, that's an x-axis reflection. Non-rigid transformations. First, a vertical stretch and shrink. When the number is out front of the function, that number is greater than 1. That's a vertical stretch. It's like if you pulled the top and the bottom of the function and made it skinnier. When that number is between 0 and 1, that's a vertical shrink. So it's like if you took the top and bottom and squashed it down, it may look a little wider. Another non-rigid transformation is when the number is multiplied inside the parenthesis with the x. This is a horizontal stretch and shrink. When that number is greater than 1, that's a horizontal shrink. So it's like you're taking the left and right and you're squashing those together, left and right. So it's going to shrink horizontally. When that number is between 0 and 1, or a fraction, that's a horizontal stretch. So you're pulling the left and the right out further. So vertical and horizontal rigid or non-rigid transformations are harder to tell looking at the graph. That's why you need to look at the function. Okay, so I'm going to do an example like the problems that you're going to do on your homework. You're going to see an equation, and then I want you to do 4 things. You're going to tell me the parent function, what it started out to be. You're going to describe the transformation. You're going to sketch the graph, and you're going to write the function in terms of the parent. Okay, so the name of the parent function. So it's like if I stripped all the numbers away before it shifted left and right, what was this function originally? So this one is a quadratic function because there's an x squared in the function. You could also graph it and see the parabola and know, oh, hey, I know this is a quadratic function. It's a parabola. So next, the transformations that were taking place. So first, I've got the plus 3 in parentheses. So that means it's going to go the opposite direction that I think, either left or right. Since it's a plus 3, I'm going to go to the left 3 spaces. Then I have the negative on the outside of the parenthesis that's not with the x. That's going to be a shift down 5 spaces. And then the negative out in front of the function is going to be a reflection across the x-axis. So I've got a shift left 3 spaces, down 5, and then a reflection across the x-axis. Okay, you can use your calculator to draw a picture of it. Make sure you plot some points. But it's going to look like a parabola opening down since it was reflected across the x-axis. And it was shifted to the left 3 spaces and down 5 spaces. Then you're going to write the transformed function in terms of the parent function. So we think of x squared is my f of x. So it's going to be negative f of x plus 3 minus 5. So if I went and took my parent function and plugged it into this, it would look correct. Negative x all squared, and the x that's squared is the x plus 3, and then minus 5 on the end. So I'm going to be looking for all 4 of these things for each problem on your homework.